What up? It's your boy C Rizzy coming at you with Unit 2, Lesson 5 and 6, Reasoning in Algebra and Geometry. Our essential question is, how can you make a conjecture and prove that it is true? So a conjecture is just a statement, and how do we prove that that's true? And our objective is to connect reasoning in algebra and geometry. So algebraic properties of equality are used in geometry, okay? So algebraic properties to you are subtracting to both sides, dividing by x. And in geometry, you accept the postulates and properties that we use as true, but some of the properties that we accept in algebra, okay, need to first be proven. So here are properties of equalities, and you guys know how to do this already. You learned this in algebra, right? So you have the addition property of equality, where you add a number to both sides of an equation. Subtraction property, where you subtract from both sides of the equation. Multiplication property, division property. Okay, that's some basic fundamentals of algebra. And then you have a couple other properties that we'll learn, and we'll use them more in chapter 4 than we will now. But the reflexive property of equality, which says 1 is equal to 1. The symmetric property of equality, which says if 1/2 is equal to 0.5, then 0.5 is equal to 1/2. They're the same thing. And then the transitive property is a little bit harder to understand, but we'll get into that. And then the distributive property, okay, is just a property that you know how to do. It's just called distributive property. So whenever you do that in a proof, you just call it distributive property, okay? And this is how we distribute. You guys know how to do this already. So in geometry, there's something called a proof, okay? Proof, and what we'll do is something called a two-column proof, where you're given some information, and there's some information that you need to prove to be true. Now, you can't prove this information in one step. There are multiple steps that go through it, okay? And in a two-column proof, your two columns are your statements, where you do all your work, and your reasons, where you explain why you did what you did and what was the reason you were allowed to do something like that. Okay, so the first statement is usually your given statement, and the last statement is always your proof statement. So let's write and practice a two-column proof with something very easy in geometry. Okay, so we're going to write a two-column proof here. Okay, so basically we're just going to prove what is x. Statements and reasons. All right, so what do we know? We know the first thing that we're given is that angle AOM and angle MOC are a linear pair. All right. We know this. This was something that we learned back in chapter 1, and the reason is because it's given. This picture gives us what is a linear pair. Okay. So our next step is that if this is true, then the measure of angle AOM plus the measure of angle MOC equals 180 degrees. Okay. Why are we allowed to write this statement? Well, that's just what the definition of a linear pair is. Definition of linear pair. All right, so we're allowed to write this. Step 3, now let's go to solve. So 2x plus 30, that's AOM, plus x equals 180. All right. What's the reason I'm allowed to do this? What's the reason I'm allowed to take this information and put it here? Well, that's just substitution. Substitution. Oopsie, sorry if it's coming out wrong. Substitution. Okay. So our next step, right, is we know we have to combine like terms. So we're going to combine this and this. So we have 3x plus 30 equals 180. And again, our reason is what we just said. Combine like terms. Okay. Now, what would be the next step in this equation? So you all know, oh, we're going to subtract 30 from both sides. Now, in a proof, you can't do this. Oh, subtract 30. Right. In a proof, you can't do this because it looks messy. So all you have to do is just know, all right, I'm going to subtract 30 from both sides. So you can do that on a piece of scratch paper. And if you subtract 30 from both sides, you're left with 150. And now what's the reason I was allowed to do this? Well, we have to go back to our table and say, oh, that was subtraction property. of equality. So we can just say subtraction property of equality. And I'm obviously going to shorten this because I don't have enough room. Okay, so that's subprop of equal, subtraction property of equality. And we know our last step is we divide by 3. And again, I can't show the work, but we know if we divide by 3, 150 divided by 3 is 50. And the reason for that is sort of what we did here, right? It's a property of equality. But which property of equality did we just do? We just did the division property of equality. So this is a 2-column proof that says, given our information, we were able to prove that x is equal to 50. Now this slide is all about properties of congruence. So there's a slight difference between properties of congruence and properties of equality. In equality, we're talking about actual values. We're talking about angles or sides or segments, and we know what their number value is. Congruence is just saying that we know a side or we know an angle are the same or they're going to be equal distances, but we don't exactly know what their numerical value is. We'll use this more in chapter 4. Okay, so let's talk about something called a theorem. A theorem is proven true. So in chapter 1, we used a lot about postulates, and postulates were just accepted fact. A theorem is something that we prove to be true, something that we can write a 2-column proof about. So we know about vertical angles. We know that vertical angles exist, and we know that they're congruent to one another. But what we haven't done is proven that they actually are congruent to one another. So this is our very first theorem, something that we can prove to be true. Other things that are proven true are that all right angles are congruent to each other. We know what the definition of a right angle is. We know that all right angles are 90 degrees. Therefore, we can prove that they are always going to be congruent. And if two angles are congruent and they're supplementary, meaning that they add up to 90 degrees, then they must be right angles as well. Right? That just makes sense, right? Supplementary means what? That means 180 degrees. So if two angles are the same and they have to add up to 180, so they're both x plus x has to add up to 180. 2x equals 180. Divide by 2, x is equal to 90 degrees, right? And we know what 90 degrees is. That's what a right angle is. Okay, so here's a problem. We know that these are vertical angles. We know that they're congruent to each other. All they want us to do is solve for the value of x. Again, vertical angles are congruent, so we know that 2x plus 21 is equal to 4x. Okay, I want to move the x's to the same side of the equal sign, so I'm actually going to subtract this 2x over here. I'm left with 21 is equal to 2x. Divide by 2. X is equal to 21 over 2, which is equal to 10.5. All right, that's all from me.